Okay, so what we're going to start with is we're going to start with our chapter on trig. And so y'all took geometry, right? Right. Dumbest subject ever known to mankind, right? So if any of you know Miss Finnan, I tell her this all the time. Like, we could just drop geometry off everything. Like, it could just go away. I mean, it's just a terrible subject. However, there is one kind of fun part of geometry, and it's the trig part. And you only got to do a little bit of it in geometry, and I know the thing you remember is the SOHCAHTOA. All right, so, right? I mean, that if you had to say geometry, you would just answer SOHCAHTOA. And so that's like a little bit of it. So we're going to talk about the unit circle, and we're going to get started. We have to talk about the types of angles. All right, so are you ready? Purple hair, Jada? All right, magenta. All right, here we go. So listen, today is the day, you guys, I'm going to establish some vocabulary. And it's vocabulary you need the whole time. And so you can't tune me out. You actually have to listen, okay? So first of all, an angle is in standard position. So an angle to be in standard position, first of all, the vertex has to be at the origin. Okay? So I have a coordinate plane with the x and y axis. And here I have the origin. So the vertex is at the origin and one ray is on the positive x-axis. So this is the positive x-axis. The other side would be the negative x-axis. But to be in standard position, the initial ray has to be on the x-axis. The vertex has to be at the origin, and then wherever the terminal side is, that determines how big, well, big isn't exactly the right word, but the magnitude of the angle. So if I look here, the very first one, the terminal side is here. It goes in a counterclockwise position, and this is the terminal side, and it's 125 degrees. And I know it has to be bigger than 90 because this is at my 90, right? So the terminal side is to this side of it, so it has to be bigger than 90. So the reference angle, so this is the standard position. Standard position. Vertex at the origin, initial side on the positive x. The reference angle is going to be the positive acute angle formed by the terminal side of the angle in the x-axis. Okay, so that's a ton of words for if this is the terminal side, what's the angle to get back to this axis? Right here, this little part right there, that's my reference angle. And it's always positive. Even though this is going the other way, we're going to call it positive for the reference angle, and it's 55 degrees. Because that would be 180 minus 125. Does that make sense? Okay, so I saw a no. So here's the initial, right? So the reference angle with 125 is from this up to this side. Well, this is along a straight line. It's 180. So if this is 125, what's left for this amount? 180 minus 125. So that gives you your reference angle. Yes? Okay. Coterminal angles are angles in standard position with the same terminal side. So, okay, so listen carefully. So what I have here, I have this 125 degree angle and it's in standard position. The reference angle is the difference between this axis and back to here. Okay? So that's the reference angle. Coterminal angles are angles that have the same terminal side. So if you look at this right here, there's a couple ways to get back to that side. So first of all, one way to get back there is to come all the way around this way. Do you see that? Okay. So how many degrees would be in the whole entire around? 360. So if moving this direction is a positive, moving the other direction is negative. So moving counterclockwise is going to give me positive, and moving clockwise is going to give me negative. So one way to get a coterminal angle is to take 360 minus that number, and that gives me the negative 225, or 235, right here. So three things. So that's one way to find a coterminal angle. I'm going to show you another way in a little bit. But so I have the standard position, I have the reference, and a coterminal means they share this side. They share the side. Okay? So if I look here, this is in standard position. This is my terminal ray. This is my initial ray. This is a positive angle, and it's counterclockwise rotation. This is a negative angle, and this is clockwise rotation. A quadrantal is a special kind of angle. It's an angle in standard position with its terminal ray on an axis. So if it's in standard position, where does the first one have to be? Here, right? And if it says that the terminal ray is on an axis, where does the final one have to be? It has to be here, here, or here, correct? And so what am I talking about? What are these? What does this make? It does make a circle, but each one of these makes a 90 degrees. So this is going to be a quadrant. And it'll be 90, 180, and 270. So when I do this, this is a positive x, right? This side is a negative x. This is a positive y, and this is a negative y. Okay. We're going to leave the degrees alone, and I'm going to start right here. A unit circle is a circle with a radius of 1 unit. A radian is the measure of an angle, and it's the ratio of the length of the arc intercepted by the radius. And so it looks like this. If this is R, this is R, and this is also R. So you told me in a circle how many degrees are there? 360. Well, there's 2 pi radians. And so how many radians would be in half of a circle? 1 pi, right? I just took pi divided by 2. Okay. So this says name the quadrant containing the terminal ray or state the quadrantal. So first of all, 120 degrees. Which coordinate? Right? 120, right, it's bigger than 90, so it's over here, so it's 2. How about 415? Why the first? 360, and then there's some left over, right? So that's the first. How about negative 20? Fourth? 270. It's a quadrantal, right? Because it's right on the axis. Okay, so 135. First of all, where's that going to be? Second. And so it's the second, so it's 90 plus what? 45, right? And 45 splits the quadrant, correct? So the 135 is going to be here. And we denote it this way. So this is 135. The 495, you just told me what happens. I have to do a full 360, right? So if I start here and I go around and I hit 360, now how far do I go? So it's 495 minus the 360. So it's 135, so that comes all the way around again and splits it. And so what just happened here? So this is 135, but this is also 135, right? These are coterminal angles. And so the first one is at 135. I found the next one by adding 360 degrees, okay? So that's going to be one way to find coterminals. Aren't we having fun? We are. So this is minus 60. What? But I'm calling it 60. That's correct. An angle has a counterclockwise angle of rotation, and the terminal side lies in the third quadrant. What do you know about this angle? So first of all, look at it has what kind of rotation? So is that positive or negative? Positive. It's in the third. It's over here somewhere. So it's a positive. We know it's positive. What is the measure between? Between what? It's between 180 and 270. An angle has a clockwise rotation and the terminal side lies in the first quadrant. So it has clockwise, so is that positive or negative? So this one's negative. And the terminal side is in the first quadrant. So it's between what? So if I'm going negative, this is between negative 0 and negative 90. Negative 90 and negative 180. So between negative 270 and negative 360. It's today. And I would have to stop recording. All right, so I want to draw a 245-degree angle in standard position. So what quadrant is this going to be in? So this goes to 180, right? So it's 245, so it's down here. What is the measure of a coterminal angle? So we subtract it, and when we do that, I go this way, right? So you get a negative. So it's going to be a negative 115. So now I want to know the reference angle. So here's the terminal side, right here. And the reference angle always goes back to the x-axis. Back to the x-axis. So here's the x-axis right here. So I want to know what's this. How would I find that? And how did you do that? Did you guess? Right, I take the 245 and subtracted the 180, and that gives me this amount right here, which is 65. And this is the reference angle. And even though it's this way, the reference angle is always positive, always. Jada, what's the question? Okay. All right. Number 4. Draw a negative 200-degree angle in standard position. So which way does this go? And so this is at like 30, right? So this is negative 200. Oh, wait, this is not negative 200. Why is it not? You guys, I didn't go far enough. Because, look, this is 180, right? Yeah, you got to go up to the second quadrant. Sorry. Bam. So, why? I make mistakes all the time. They know it. Okay. So, So 360 minus 200 gives me what? And that's, it says a coterminal. Is that the only coterminal? How can you find another one? Like, so this was the positive one, right? So what's another one? Come up with it. So 160 plus 360 gives you what? 520. So look, Jada, if I went here, correct? So to get back to here, I could do another complete circle, correct? which is 360 degrees. So I added the 160 plus 360 and got 520. Correct. You could keep going. All right. So what is the reference angle this time? So this is 180 and this is 200. How much did I go past the x-axis? 20. So the reference angle is 20 degrees. Do all angles have both positive and negative coterminal angles? Yes. By adding or subtracting. Thank you. Adding and subtracting either 360 or 2 pi, right? Because 2 pi would be a complete circle also. The answer is yes, and it's always acute. All right, go to the other sheet. I'm not holding on. Move it. I know time to hang out. Okay. Okay, so from the notes I just gave you, this is 0 degrees, but it's also 0 radians. How much time is left? How much? This is going to be real quick. Hang on a sec. Okay, so this was 90 degrees. This is 180 degrees. And this was 270 degrees. And then back to 360. So 0 and 360 are in the same position, but I've made one rotation. So I start at 0, I do a rotation, I'm back at 0, but that's 360 degrees. Does that make sense to everybody? Okay, so the other thing I want to say is we just talked about that one complete rotation in radians was 2 pi. So 360 is 2 pi. And we said that 180 was half of that, which is pi. So what would half of 180 be? 90, which would, if I halved pi, I would get pi over 2. Now how would I get the 270? Close. So listen, I have a pi plus a pi over 2. Okay? Yeah. So look, here's what I have. I have pi plus pi over 2 to get to 270. So I got to have a common denominator to add these, right? That's correct. So look, could I say this is 2 pi over 2? Why not? It does, and it makes it 1 pi. So when I add these two together, would I get 3 pi over 2? I would. Oh my gosh. But when you said 1.5 pi, what is 1.5 as a fraction? 3 over 2. 3 pi over 2. It's all the same thing. Look how fun this is. All right. right, so watch. Let's finish so Shannon can go. To convert from degrees to radians, we're going to multiply by pi over 180. To convert from radians to degrees, we're going to multiply by 180 over pi, the opposite. No, we are not doing a calculator. So, all right, so to convert 60 to radians, what am I multiplying by? Pi over 180. So the 60 cancels into 180, and I get pi over 3. I know, you're about to be sad, Jada. Okay, 105 times pi over 180. Always. Okay, so what can I reduce? 105 and 180. What can I reduce by? I didn't. Thank you. I did not stutter. Can they both divide by 5? Yes. And so if I divide both by 5, what do I get? I get 21 pi over 30. Shh. I'm thinking. 15, 30, 36. 21 over 36 also reduces by 3 again. So it reduces to 7 pi over 12. Yes, this is how you will leave it. Okay, so minus 330 times pi over 180. Reduce. For sure it reduces by 10, so I can get rid of the zeros. And then I can also reduce by 3, which gives me negative 11 pi over 6. Yeah. All right. So when I'm going the other way, and so here's the easy way to remember this. So to convert it to radians, you have to have a pi. To convert it back to degrees, you can't have a pi in your answer. So I want the pi to cancel out, so the pi has to go on bottom. So I'm going to multiply all these times 180 over pi. So the pi's cancel out. And what can I do here? If I divide 4 into 180, what do I get? Which is 7 times 45, which ends up being 350 degrees. I'm going to cancel the pi's. The 2 goes into 180 90 times. So negative 3 times 90 gives me negative 270. And when I cancel pi's, 180 divided by 12 gives me 15.